Welcome to today's webinar, Purpose-Built Backup Appliances, what they are, when to choose them, brought to you by WD. And I'd like to introduce you to our presenters today. We have Bill Evans on the line, and he is the Senior Product Manager at WD. We also have Vineet Gupta on the line, and he is, like Bill, a Senior Product Manager at WD. And last but not least, we have Britton Spagnola on the line, and she will be there to get all of your questions answered. So as you enter them, she will make sure to get them over to Bill and Vineet to get those answered. So with that, I think I have all the housekeeping done. Bill, take it away.
Thanks, Abby. Good morning, everybody. My name is Bill Evans, and I'm an employee of WD based in our offices in Mountain View, California. Today I want to share with you some insights about purpose-built backup appliances and what you should know to decide if PBBAs make sense in your environment. But before I do, I want to remind you that not only is Western Digital the world's largest manufacturer of hard disk drives and a major provider of consumer direct attach storage and NAS, Western Digital also has a line of products for small and medium businesses. These products include network attached storage and network backup appliances and software. WD expanded into network backup products for SMBs with the acquisition of Archaea software at the end of last year. So in the deck I have for the webinar this morning, I want to discuss the evolution of backup. I want to talk about a few trends that have led to the emergence of purpose-built backup appliances. We'll discuss exactly what makes an appliance qualify as a PBBA, and we'll discuss the dimensions that you should evaluate when you're trying to choose whether or not a PBBA makes sense for your environment. First, I can't emphasize enough the continuing importance of backups. Purpose-built backup appliances are important because backups are important, and backups are important because your data is important. Kroll OnTrack reports that about 40% of data loss is due to hardware failure, and some of this hardware failure, like the failure of your disk drives, can be prevented using RAID systems. But other hardware failure and all the human failure, computer software failure, and malware, as well as natural disasters out there, can't be protected by simple solutions like RAID. What you need is a backup solution to allow you to roll the clock back so you can recover your data as it was at any point in the past. So the purpose then of backup is to let you establish a series of restore points in the past. And recovery using backup solutions lets you turn the clock back to any one of these restore points. For example, you might have a restore point at 10:30 a.m. on January 20th, 2013. But you probably don't want just one restore point. The considerations you have to take into account when you design a backup solution are several. One of them is you need, of course, to decide whether you want to back up to target tape or target disk. Historically, most everyone did backups to tape, and it was only less than 10 years ago that people started doing backups to disk, though even today many of those backups to disks are replicated to tape for offsite storage. But that's the first decision you have to make when you're deploying your backup solution, and you can use PBBAs for either kind of deployment. Another consideration is the frequency of your restore points. You can establish restore points hourly, daily, weekly, as frequently as you would like. The more frequently you establish restore points, the less data you can potentially lose. The disadvantage of very high frequency restore points is it takes both CPU and network resources, as well as additional storage to maintain these restore points. A third issue to consider is the use of full, differential, or incremental backup technologies. These different types of backups were created many, many years ago, probably over 50 years ago, to accommodate tape and the generally high cost of storage. By doing incremental backups, you can reduce the amount of data that has to be written to tape in establishing a restore point. You do this by only backing up the files that have changed since the last restore point. So these incremental backups make it possible to have many, many more restore points with the same volume of data than you might otherwise be able to have. The downside of doing these incremental backups is that in the case of tape, it can slow your recovery process, because rather than restoring tapes with only data that you want to recover, you may have to mount many different tapes, taking only a little bit of data off each tape. Today, if you use backup to disk, the concept of full, differential, and incremental backups almost is no longer relevant, because deduplication technologies make every backup effectively an incremental backup. The final dimension you need to consider when you're deploying your backup solution is where you're going to store your backups. Some people still do backups on site that are stored on site. I can't stress strongly enough, and WD as a company feels very strongly, that you don't have a backup that you can depend upon until you have a backup that's stored off-site. If your site's destroyed, whether due to natural disaster or theft or human error, you don't want to lose your backup at the same time as you lose your production data. Another concept relevant to the advent of purpose-built backup appliances is target storage. Over 50 years ago, backups were done almost exclusively to open reel magnetic tapes. These 9-track tapes had a separate tape housing for the tape and a separate tape housing for the take-up reel, so 2 separate reels. And each tape had to be mounted by a human. This was a great job for college students who could spend their nights changing tapes in a machine room. Open reel tapes, though, lost favor with the invention of cassette tapes. Cassette tapes were different because the reel and the take-up reel were both in the same cassette, in the same mechanical device, and cassettes could be managed very efficiently by autoloaders or tape libraries. This means that you could have a tape library with perhaps a dozen tape drives that could read or write the tapes, along with hundreds or thousands of slots. And the tape cassettes would live in those slots, and a robotic arm would take tapes out of the slots and put them in the tape drive, leave them in the tape drive until the tape drive had finished its work, and then return the tape to the slot. It was a very efficient way to do large backups to large volumes of tape without requiring human intervention. Tapes are still relevant today. In fact, the vast majority of medium and enterprise businesses out there use tapes as their final backup target. But the impact of tapes is declining with the advent of very highly reliable hard drives that are proving to be very, very efficient, very, very price efficient. The catalyst for this, of course, was the invention of the PC, which motivated the much greater attention to the low-cost manufacturing of hard drives. Still another thread relevant to the delivery of purpose-built backup appliances is the evolution of backup from one tape device per computer to network backup. In the early days, computers were expensive and tape drives were expensive, but pairing them together for backup made sense. As computers became less and less expensive, but these mechanically complex tape drives did not, a new way was required to reduce the costs of backing up multiple inexpensive machines. And this way was provided by network technology. Network backup then consists of a single backup server on a network backing up perhaps as many as hundreds of machines on that network and storing all of those backups at on a single target storage element, whether disk or tape. The purpose of network backup was not only to reduce the costs of doing backup, but also to simplify the management by limiting deployments to a single backup server per LAN. So we've talked about a couple trends that have driven purpose-built backup appliance adoption. Clearly, the transition from tape to disk has been essential. Purpose-built backup appliances exist today because disk is a popular target for backups. You can put a tape drive in a purpose-built backup appliance, but you certainly can't put a tape library in a purpose-built backup appliance. And so the trend is that virtually all purpose-built backup appliances have disk in them. Some have both disk and tape drives. Another trend driving PBBAs is a change in business requirements. It used to be that most companies, even substantial mid-sized companies, would have only a single data center and all backups would be performed in that data center. So all of the technically skilled staff in that IT organization, they could bring their skills to bear on the deployment and the maintenance of that backup server and target storage. Today it's different. Today most companies have multiple offices where data is created, and each of these offices requires its own backup infrastructure. This has been one of the significant motivations for delivering PBBAs. You want a backup solution in environments that don't have heavy technical expertise. Another trend that we've seen, and this is relevant not only to network backup but to other product categories, is there's been an increasing preference on the part of IT organizations to buy appliances rather than to build solutions. So buying an appliance from a single vendor makes it faster to deploy the solution and makes it simpler to support. It's a reflection of the one throat to choke strategy. So the term PBBA was coined several years ago by Robert Amatruda, an analyst at IDC. Amatruda observed that PBBAs were not just an anomaly, but were becoming a product category in and of themselves. The first purpose-built backup appliance was delivered by Avamar, today part of EMC, in 2006. So a good 7 years ago. The second purpose-built backup appliance was delivered by WD Archaea in 2007. And since then, many more companies have started to deliver purpose-built backup appliances. Again, what makes them special is that they're standalone backup servers with integrated storage targets. You would always connect them to a network in order to get to the machines that you want to protect, but you would never allow a purpose-built backup appliance to run any other workload or application. This is, on the one hand, a limitation of PBBAs, but also a reason why PBBAs have proven to be such reliable backup servers. PBBAs are significant because they are an example of an appliance where hardware is fine-tuned expressly for that one application, for that backup application. So everything in the PBBA, from connectivity to disk storage to the CPU necessary for dedupe processing to the use of tape drives or SSD, all of these technologies are engineered to make it possible to deliver a complete and perfectly balanced backup server. Now, when I talk about purpose-built backup appliances and the fact that they've existed only since 2006, you clearly infer that there are other ways to deploy backup servers. Obviously, before purpose-built backup appliances, most people deployed backup servers as a software application. You'd license the software, you'd buy hardware, you'd install an operating system, and then you would install your backup server. And this is the way it was done universally until 2006. Another option that became possible subsequent to the delivery of purpose-built backup appliances was the delivery of backup servers as virtual appliances. Virtual appliances take the firmware that would otherwise exist in a purpose-built backup appliance and deploy it on a hypervisor, whether Hyper-V or VMware or another brand of hypervisor. So all in all today, you have three ways to deploy backup servers, either as purpose-built backup appliances, as software applications, or as virtual appliances. In the next several slides, I want to review how each of these different strategies for deploying a backup server matches up to several dimensions that are important in your decision-making process. So we'll evaluate the three alternatives for deploying a backup server and see which fares best according to different criteria. So the first set of criteria we're going to look at is that of technical expertise. If you consider the three choices for backup server deployment, you'll see that PBBAs rank very well in this dimension. PBBAs require very little technical expertise to deploy and maintain. Effectively, you plug it in, you set an IP address, you install your agents, and you start a backup. Of the three alternatives, it's the easiest. By comparison, a software application requires the most technical expertise. There you have to get the hardware, the OS, you install the software, you configure the storage, you install the agents, and then you start the backup. It's a lot more work. And even if you have teams at headquarters that are able to perform the work to deploy a software application, it's simply sometimes more cost efficient, certainly more time efficient to have a PBBA be deployed because that takes a lot less expertise and more people are able to do it. In the middle between high technical expertise and low technical expertise is the virtual appliance. It's almost as easy as the PBBA, but it requires just a little bit more expertise with virtual environments. Another dimension for the evaluation of PBBAs is speed of provisioning. If you want to deliver a PBBA, it's going to take little time, it's fast, but there are a few physical steps. This makes it slower than deploying a virtual appliance. MSPs, managed service providers, have adopted virtual appliances broadly because virtual appliances can be deployed effectively on demand. The deployment of a virtual appliance can be scripted, and deploying multiple virtual appliances in minutes is now practical. So this makes sense for data centers that have multiple LANs and very large numbers of distinct customers that need to be protected. And as you'd expect, it's the software application that's deployed the slowest. It's a manual process. You get what you want, but it takes time and you need the technical expertise to do it. Still another dimension to evaluate your options of backup server deployment on is that of physical security and isolation from production systems. Here, PBBAs rank quite high. PBBAs have the advantage that they are on dedicated hardware. The hardware is running a hardened OS. The OS is hardened because all of the services not necessary for the backup server are terminated and do not start at boot up. The operating system is also hardened by virtue of the fact that all the processes that listen to ports do not listen to ports in a PBBA. All of those services have also been turned off. So by virtue of having the hardware physically separate, sometimes even in a separate room, and by having a hardened OS, your machine and your data are much better protected than they would otherwise be. The other end of the spectrum is the deployment of a software application. Software applications are the least secure because they're deployed on shared hardware, and by virtue of being deployed on standard operating systems, more often than not, the software application can be vulnerable to malware. In the middle between PBBAs and software applications are virtual appliances. You get exactly the same hardened OS as you get with a PBBA, but the shared hardware puts you at a small incremental risk. There's still more dimensions. One issue that comes up frequently is the issue of how do I get my backup sets off-site? And as most of you know, the traditional solution for getting backup sets off-site is to write those backup sets to tape and then to ship those tapes off-site in a truck. Today, more and more people are looking at alternatives to tapes on trucks as a way of getting their data off-site. All of this is a preamble to explain what seed and feed means. Seed and feed is a technology that WD Archaea offers, and similar to technologies offered by other companies, that make it practical to move backup sets off-site on physical media. So if you don't want to use tape but you want to use disk, using disk generally requires that the backups are moved off-site over the wide area network. The problem with moving backups off-site over the wide area network is the limited bandwidth that you would have available to you. Bandwidth can be very expensive. So seed and feed is a technology that lets you export a backup set from one backup server, ship it either via SneakerNet, via FedEx, or via UPS to some remote location, and then to import the backup set to the backup server at that remote location. So seed and feed uses USB-connected portable media as an alternative to using a wide area network. And seed and feed is very cost effective because you can move very large volumes of data quite quickly. The latency is high. FedEx takes a full day to confirm that they've delivered the USB connected hard drives. So latency is high, but the bandwidth is also very high. So rather than provisioning a network of 1 gigabit per second between your site and the remote site, you're able to take advantage of a much smaller bandwidth and send nightly backups over the wide area network. But for big backups like your first backup and for disaster recovery, you move data not over the network but by sending these portable media, these USB connected hard drives. So with that introduction, PBBAs are a no-brainer for doing seed and feed because the PBBAs, as in the case from WD Archaea, are configured to serve that function. The USB ports are present. They work with portable hard drives. The USB ports are configured so that you can export and import data. It won't be possible to boot the system off those hard drives because it's all configured correctly. By comparison, a software application will let you do the same thing. The capabilities exist in the software application, but there's going to be a little bit more effort. You have to make sure that you have access to the USB ports, that they're not used by someone else, that the hardware hasn't been dedicated to some other purpose. And this problem exists both for software applications and for virtual appliances. So PBBAs are a nice fit for using seed and feed is an alternative to off-site tape delivery. Another difference between PBBAs and software applications and virtual appliances is present in the fact that PBBAs are fully engineered solutions. This is a benefit not to be underestimated. PBBAs are designed and tested and often certified by engineering organizations that have been able to tune every element of the PBBA to the purpose of the backup software. You can do the same thing with the software application, but again, the engineering process to select the relevant hard drives, to size the CPU, to size the memory, to harden the OS, this is a substantial engineering undertaking. And if it's done once in the context of a PBBA, it's certainly going to be much more cost effective for you to take advantage of it than to recreate the wheel. So PBBAs rank very high on the metric of engineered solutions, where software applications and virtual appliances require a lot more effort on your part. The final criteria on which I want to compare PBBAs to the other deployment modes is shown on this flexible configuration slide. PBBAs rank very high on several dimensions, but not on the dimension of flexibility. If you want particular network connectivity, if you want a particular combination of fiber channel and InfiniBand and 10 gig ePorts, if you want special precise models of disk or precise models of SAS controller, or if you want a special kind of memory or SSD, if you want to truly customize this because you know your requirements better than anyone, then a software application is unequivocally the way to go. Software apps give you infinite flexibility. PBBAs give you a minimum of flexibility. You can generally only choose among the dozen or so appliances that are offered by a vendor. But that is the price you pay for having a fully engineered solution. In the middle is a virtual appliance. A virtual appliance is certainly more flexible than a purpose-built backup appliance, a hardware appliance, but not nearly as flexible as a software application would be. So this slide sums it up. You've seen that for this series of a half dozen different criteria, that PBBAs rank pretty well. PBBAs are the best choice if you want to keep technical expertise low, if you want maximum physical security and isolation from other production systems. PBBAs are a great idea if you want out-of-the-box seed and feed functionality, and you want the benefits of a fully engineered solution. On the other hand, if you want maximum flexibility, a software application is for you. There is no other way you can get the same flexibility in your deployment of a backup server. And if you want speed of deployment, then the virtual appliance seems to be the best choice. Being able to script the deployment of a virtual appliance is something that makes it, again, particularly attractive to managed service providers. So that's the background I wanted to provide on the choice of purpose-built backup appliances. They're a great tool in the arsenal of systems administrators, but they're not the only way to deploy backup servers. So certainly consider your options before you choose. In fact, you may find that today the best solution for you as a small shop might be a purpose-built backup appliance, and in the future the best solution might be something different, either a virtual appliance because you've adopted virtualization, or a software application because you need the scalability that it provides. To this extent, you'll want to focus on companies that can deliver your backup server in any one of these three configurations, which, not surprisingly, WD Archaea does. Now, to satisfy the powers that be, let me, in a couple slides, tell you a little bit about Western Digital. Western Digital is a company of almost 100,000 employees. We are the world's largest manufacturer of hard disk drives. It's primarily us and that other company. Western Digital is headquartered in Irvine, California. We've been around for over 40 years. We have over $15 billion in revenue. We began with the manufacture of disk drives in the late 80s, expanded that to deliver solutions to consumers sold through retail, and you may know us that way, and more recently started delivering solutions to small and medium businesses in 2011. In 2012, we acquired Archaea Software and their network backup solution. The WD Archaea network backup solution was first delivered in 1999. It's a mature product, a proven product, a product that's been very successful in the marketplace. The WD Archaea backup servers, as I suggested earlier, can be deployed as appliances, as purpose-built backup appliances, but also as virtual appliances and also as application software. WD Archaea protects more platforms than any other backup solution on the market. WD Archaea protects all the major virtual platforms, VMware, Hyper-V, and Zen Server, as well as all the major physical platforms. Windows since Win98, Linux, Mac OS, NetWare, the three Unixes, AIX, Solaris, HPUX, as well as the Berkeley Standard distribution. We're best known for some technologies we have for fast backups. We have a patented technology for deduplication called progressive deduplication. We also have a technology for multi-flow. The multi-flow technology allows us to back up multiple clients in a single pass so that the performance of the backup is not limited by the performance of any one of your client machines. Finally, the WD Archaea products are delivered strictly through distribution through our channel partners worldwide, and today we have over 100,000 customers in 100 countries. On the upper right of this slide, you can see a screenshot from our web user interface, and in the lower right, you can see two models of our backup appliances. The upper image is our 4300T with an integrated LTO5 drive, and in the lower right, a 6300 appliance with capacity of 48 terabytes of storage. And then in my final slide of the presentation, I wanted to review with you the architecture of the WD Archaea product. WD Archaea has the classic network backup architecture. That is, a single backup server on a LAN controls multiple backup agents. Each of these backup agents is installed on a machine that has data that you want to protect. So the backup server will call the agents, take data off the machine, and write this data to the target storage device. You control the backup server either via a graphical web user interface, and that's ideal for direct interaction with the backup server, or you control it via a command line, which is ideal for scripting. The storage devices that we support include any file or block storage, as well as over 600 kinds of tape drives and libraries. We also back up to public or private cloud. If you have multiple local area networks and you want multiple backup servers, you can manage multiple backup servers and even do replication between backup servers. This is the primary mechanism that we use in order to move data off-site. you would establish a backup server on-site, another backup server off-site, and replicate backup sets from one to the other. Now, the backup servers all support backup replication, and all the backup servers can be delivered in one of three modes, as we discussed earlier. You can deploy a backup server as a software application, and that software can run on any of over 130 different Linux platforms, but the backup servers run on Linux. The backup servers alternatively can be appliances, again, purpose-built backup appliances, and the range of disk runs from 1 terabyte capacity up to 48 terabytes of capacity, and some of these models include integrated tape drives. All of the models can be connected to external tape drives and network connected to external storage. And then finally, you can deploy your backup server as a virtual appliance, and these can be deployed on either VMware ESX or ESXi hypervisors. Now, the backup agents that we deploy can back up files on over 200 different platforms. I mentioned the platforms in the previous slide. These platforms are a combination of computer architecture and operating system. So if you have a machine with data on it, chances are pretty good we have an agent that will protect files on that machine. If you have more than files, if you also have database servers or applications or directory servers, we also have specialized backup agents that can back up these databases and applications using a hot backup. You don't need to power down your database or your application. We can back up MySQL, Oracle, and SQL Server while they're running, making use of the APIs that those database vendors provide. We can do the same with applications like Exchange or SharePoint, and we can do the same with directory servers. Also on the agent side, we're able to protect VMware environments using the vStorage API for data protection delivered by VMware, and protect Hyper-V environments using the VSS infrastructure provided by Microsoft. We do deduplication on both the agent and the server. We do encryption on the agent, and we provide bare metal disaster recovery. So that's it. In a nutshell, this is the architecture of WD Archaea version 10 that is available today. For more information, please go to our website, www.archaea.com, or send me email at william.evans@wdc.com. And so now, without further ado, Britton, I understand that you have some questions that you've collected from the participants.
Yeah, we had quite a few questions come in during the presentation, so I'll start off by asking the first question. Are tape backups still relevant since solid-state drives are still at a high cost and mechanical drives aren't as reliable as we would like them to be?
I think that the question was very well phrased and included its own answer. Yes, tape is still relevant. Tape is relevant not so much because hard drives aren't reliable, because hard drives are extremely reliable, especially when they're configured in RAID or used for replication. But tape is especially valuable because for cold storage, nothing beats the price of tape. And if you want to move data off-site and you don't have the bandwidth over a wide area network, you don't have the internet connectivity, then you can put 100 tapes on a truck and ship them off site much more reliably than you can put 100 disk drives on a truck, hoping that after a bumpy ride they'll arrive at their destination. So absolutely, tape is still relevant. That said, it's becoming less and less popular as a target.
Okay. Next question. Isn't it cheaper to build your own appliance?
Well, we invite you to give it a try. It may be possible to match the cost of a purpose-built backup appliance by building your own, but it does require very substantial expertise, and it does take time. And it may not even be possible to do it. One advantage that manufacturers like Western Digital have is that we buy all of our components in very large quantities, so we're able to negotiate prices that are dramatically better than any individual could get otherwise. But it's certainly an alternative to build your own, and we invite people to give it a try and let us know how it goes.
So we did have a lot of questions around the price of the WD Archaea appliances. Can you give a price range starting at the 1 terabyte and moving up to the 48 terabyte appliances?
The price of our entry level purpose-built backup appliances is just I believe starts close to $39.95 for our smallest appliances, and then the largest appliances cost upwards of tens of thousands of dollars. The precise purpose-built backup appliance appropriate to you is going to depend on your workload, the volume of data you have, and so on. We have a variety of different appliance capacities in terms of CPU and memory, and each of these comes with multiple disk storage capacities, some with or without integrated tape. So I'd ask you to either send me email or contact us via the contact page on our website, and we'll get somebody who knows the prices to get back to you.
Okay, and this next question is pretty technical, so I'll see if you can answer it, Bill. How do you do a cloud-based backup on, say, 200 gig Exchange database nightly?
I didn't get how big was the Exchange database?
200 gigs.
Oh, okay. So not a particularly big database. The challenge of doing any cloud backup is imposed by the bandwidth that you have. If you have a 1 gigabit fiber line, you can back up a lot of different stuff. If you have a 10 megabit line, you're going to be much more highly constrained. So that's the first factor, the amount of bandwidth you have. The second factor is what will be the impact of deduplication on your data set. Because if every night you're doing effectively an incremental backup of your Exchange data set, the question becomes how much is one day's Exchange backup going to be similar to another day's Exchange backup. It's the difference between the two that is the data that you'll have to push up to the cloud. And this depends on the data content in your Exchange database. Also on that subject, I don't recall whether Exchange in its current incarnation of 2010, whether it provides a mechanism for incremental backups or not. You can get much of the same benefit by doing a full backup that's deduped, that effectively gives you the results of an incremental backup, but it would be faster to use Exchange's own mechanisms for incremental backups. If the person who asked that question could provide an email address, I can get someone who knows this subject better than I to get back to you with an answer. But those are the two big issues: how long it takes to do the backup in the first place, based on incremental or the use of deduplication, and then second, how much bandwidth you need to move it off-site. That's the challenge of the cloud backup.
Okay, and one last question. How does the WD Archaea virtual appliance perform on Server 2012? Does it support backing up deduplicated data from Server 2012?
The Archaea virtual appliance runs on ESX and ESXi hypervisors. So if you deploy the virtual appliance on one of those VMware hypervisors and you install our agent software on a Windows 2012 server, we're able to back up the data on that Windows 2012 server. That data can be backed up such that it's deduped on the 2012 server, or such that it's deduped on the virtual appliance. You can choose whether it's source or target dedupe. Generally, we recommend that you use source dedupe to minimize the amount of data that's pushed over the wire. 2012 is an incremental improvement over 2008 R2. We think 2012 is a very good piece of software. And we think that the WD Archaea backup servers and agents are a good fit, as we are for other platforms. I may not have answered the question, and if not, if the asker could send a follow-up email, I would be grateful. Any other questions, Britton?
Nope, that will conclude the Q&A portion of the webinar, and I'll hand it back to Abby.
Okay, well, thank you so much, Bill. That was a great presentation, and Britton for getting those questions answered. Just wanted to let everybody know that, again, or remind everyone that they will get an email with a link to that recording, the recording of this webinar, in about a week. So be on the lookout for that. And also, when we close down, if you notice at the bottom on your little widget dashboard, you'll see a red checkbox with, if you click on that, some survey questions will pop up, and we'd really like you to take the time to answer a few of those for us. And with that, just wanted to, again, thank WD for doing the webinar today. And Bill, did you have any closing remarks?
No, thank you, Abby, for hosting, and Britton for coordinating the questions, and thanks to Vineet for being my backup on the Q&A.
Awesome. Well, then, with that, I just want to thank again everyone for being on the line, and we'll see you on future webinars.